I think we're outstanding.
That's what the people want.
I can just stare at the camera dead like this while he's talking. After like 5 minutes of watching this shit, I want to have a new skill. Yeah, wait, you're getting paid? I don't know how to dance. All right. Hey guys, welcome to this episode of Cutting Corners with Jim and Jake. Today we're talking about threads, thread engagement, everything you need to know about tapping, threading, whatever.
Yeah, so one of the first things you got to know about tapping a hole is that you need to have a hole to tap, right? So have some kind of through hole, or I guess in some materials, blind holes. But I guess what's the first thing that you need to know when having a tapped hole or a drill size hole?
So traditionally, like if you're doing it yourself in your garage, you have to know exactly which drill size to put in your material so that you have perfect thread engagement. You've all referenced those drill charts that have like, they go out to what, 10 thou or something like that, plus or minus, 1 thou accuracy in order to have a good tap. That was always a pain in the butt for me. So at SendCutSend, what we try and do is take all that calculation off of your plate. If you have a hole and you want it tapped to 1/4-20, just put any hole on there that you want, up to about, what, 2.9 inches, something like that?
Yeah.
We will shrink it or expand it in order to give you the perfect thread engagement.
Exactly. And so that leads us into thread engagement, right? And so having the correct size hole is all about making sure that you have the correct size thread engagement. And so that enables for good thread kind of a strength,
Yeah.
right? And when we talk about thread engagement, what we're actually talking about is how much connection there is between the bolt and the threaded hole, right? And so we can kind of come over here real quick and draw this. If I draw a big triangle, and this is like one thread, and I have my male thread coming in, the amount of engagement right here is typically what we're looking for. And the standard is like 70% thread engagement.
Yeah.
So you do want a void in here. You want a little bit of a void, and you want 70% of your threads touching. If you drill too large of a hole when you are, doing your pilot, you are gonna end up making this come back because the outside of your thread is gonna be the same from your tap, and you are gonna now only have, say, 50% thread engagement, 30% thread engagement, and that causes a weaker thread in the end, and you're gonna end up having your threads pull out. The opposite is that if you have too small of a through hole, right? Then you have too much thread engagement. They're going to bottom out. You're going to see this breaking a lot of taps, or you're going to see galling, just too much contact, too much interface there. And so one of the things that we do here at SendCutSend is that we have go, no go gauges at each of our tapping stations and stuff. And this is to double check that we are within tolerance of those through holes. What they do is you have one side. So there's kind of a double barreled little tool. One side is a go and one side is a no-go. And so the go, we would expect it to go through the part, through the whole tap side. The no-go should stop a thread or two in, and that is a good indication that we're within that tolerance. So, so how do we make the threads though?
With a tap?
With the tap, yeah.
Do we have?
I mean, you have it written down here, so I was just leading you on to the next topic.
Okay, I guess I'm in charge of doing like the basics because he knows all the ultra technical stuff. Basically what we're doing is we're taking a hole that is the perfect size, and then we're running a very hard material in the shape of threads through it in order to swage those threads out basically. We are doing a little bit of chip cutting as well, removing the excess material. But it's a very precise operation, especially in smaller, smaller diameters, like a really fine metric or whatever. You have to be incredibly accurate. Otherwise, when you put your hardware in there, it's going to be loosey-goosey, or you're going to go to put it in there and it won't go. So that's, again, why we size all the holes for you. A really easy way, the way that I design stuff for SendCutSend is if I just know I need a 1/4-20 hole, I'll just put any size hole there that I want. 1/8 inch, 1/2 inch, it doesn't matter. If I'm using 1/2 inch holes somewhere else, I'll grab one, put it there. And then I know that during the configuration step in SendCutSend, I can say this geometry, I want it to be 1/4-20. We will size it to whatever drill diameter that is, and then I'm good to go. I'm guaranteed great thread engagement.
Yeah, exactly. Nailed it. Yeah. There is a big difference between imperial and metric. And so in the background, the way that we call out an imperial thread is typically
Freedom units.
Freedom units. You want me to draw an eagle when I do this?
Yeah, or there should be an eagle coming through here.
So an imperial would be called out something like this, where this is your diameter and this is your thread pitch. I'll say TP. And on that thread pitch, get it, Vanna.
No, I'm just helping.
Yeah. On the thread pitch for an imperial thread, it's how many peaks there are within 1 inch. So you would measure from this peak and you would measure over 1 inch and count the peaks. And so on a quarter 20, it'd be 20 peaks for that inch. If you have a finer thread, it's gonna be more peaks. So a quarter 28, it'd be a fine thread. Quarter 20 would be the coarse thread. On metric, it's done a little bit different. So it is the measurement from peak to peak. So if you have an M8 by 0.5 or 1.5, what you're gonna end up seeing is 0.5 millimeters from peak to peak or 1.5 millimeters for the thread
coarse
pitch.
Yep.
So it's kind of the inverse, right? So 0.8 would be fine, 1.5 would be coarse.
Yeah, so if you never knew what that meant, that's what it means. So when you're selecting hardware from somewhere like McMaster or whatever, that's a quick way to indicate, am I getting coarse or fine thread? If you're doing NPT, I don't know how to help you. No one knows how that works.
It's all about the taper, right?
Just bought the hole. I think I already covered that, which is just put it there. We'll shrink it or open it up as needed.
Yeah.
Things to avoid.
Thin materials. Thin materials have less thread engagement, and that's because, yeah, get it.
So if this was my material and it's only that thin, I'm gonna have like 1 thread or 0 threads of engagement. Not gonna work very well. It's not gonna be strong. This fastener is gonna pull out really, really easily. So
one way to get around that is to have finer threads, right? So you get more thread in
you want,
there.
I mean, rule of thumb is like what, 3 or 4 threads, basically, minimum?
Nailed it, yeah. 3 to 4 threads do most of the work, do 90% of the work. The more threads, if it starts failing, you have more threads to kind of, it's insurance policy. But yeah, you want 3 to 4 threads. So the fine pitch can kind of get you there, but you know, there's a give and take to it.
Yeah. So if your application has to have very thin material, we recommend PEM Hardware. We do a PEM cert in there, and you can have as many threads as you want, you know, depending on the nut or stud or standoff that you pick.
Exactly. And we did a full video on PEM Hardware, so go check that out in the link below. Another thing
just
to
make
avoid,
it hard on Dennis and
I was going to put it over here.
Okay.
Okay. Stainless. So why would stainless be something that we want to avoid?
Stainless is a terrible metal to tap. If you've ever tried to tap stainless in your garage, in your vise, with your Harbor Freight tap kit, you know my pain. So stainless is a material that galls almost instantly. It doesn't cut nice chips. Yeah. So as you go in there, it's gonna break your tap. It's gonna cause all kinds of problems. Yes, it is possible to tap stainless. It's just a huge pain in the butt, and we avoid.
If you do tap stainless, I highly recommend that you do not use stainless hardware with your stainless tapped hole, or you will be remaking those parts with us very shortly after.
Yeah, or it's one-time use. You put stainless hardware into stainless, it's almost like a weld.
Exactly.
Yeah.
So the next thing, size. So with that, super large parts, super small parts have restrictions, mostly because of the work environment and stuff that we have.
Yes, for us to fixture, whether it's very small or very large, it's difficult for us to fixture a part the size of this table and get all the taps into it with our equipment. So we avoid very large stuff.
Yep.
And then same thing goes with very, very small stuff. I remember one of the very first jobs that we got when we opened up tapping was about 100 pieces about the size of a dime with a tapped hole right in the middle.
Yep.
And it was almost impossible for us to grab onto it. So that's why we have the minimum size as well.
Exactly.
And the thick.
And
thick with 2 C's.
Thick with 2 C's.
As material approaches, you know, over a ½ inch or around a ½ inch or whatever, some materials like chromoly can start to behave a little bit like stainless, where they're going to start to gall, they're not cutting good chips. So we will limit how thick we can go on a very small subset of our materials.
Yeah, exactly. The ones that are going to harden a little bit on us. And stuff. One of the things that you already kind of touched on is a great alternative is PEM Hardware.
Yes.
And it's one of those things that we offer. We auto size, so it's the same thing where you can just spot your holes, changes nothing. It adds more threads to your thinner materials. It's also corrosive resistant. There's a lot of benefits from it.
And if you can't use PEMs though,
Yeah.
Helicoils,
Yep.
time certs, stuff like that will get you where you need to be. I learned about helicoils when I was about 16 and blew some spark plugs out of my cylinder head. So helicoil is traditionally known to repair a thread. However, there are applications where you can go into a, any hole and thread it with a helicoil or a time cert, stuff like that. So.
Exactly. Another one is
Rivnuts.
Rivnuts.
Yep.
Yeah, Rivnuts. They really come in handy when you don't have access to the back of the hole. They're an application where you have one-sided application. The tools are really easily available. You can get them on Amazon, Harbor Freight. You can get Rivnuts anywhere.
It's just like a little kit with some pliers. It comes with some Rivnuts.
Just like a rivet, but it has a hole in it that's tapped. Right?
Just reef on it though, because the last thing that you want to happen is a Rivnut that slips, especially when it's on your dashboard that you just reassembled with all your gauges in it, and then it starts to spin. Then you are screwed.
I always slide a little bit of bond, like some kind of panel bond
like
or
panel
something on the
bond,
back of it, and then it'll keep them slip. Yeah, that's a little tip, a little side tip.
Anything else? I think that's it. So to get a price on your tapped parts, feel free to upload your DXF or step file to SendCutSend.com for instant pricing.
Yep, and go check out our merch store. We're always adding more. If you are interested in advertising with us, reach out to our marketing team and we can feature you on these episodes.
Yeah, thank you to today's sponsor, Red Bull Watermelon.
Yeah.
It's tasty.
There you go.
Love you, bye.
Love you, bye.